So today, we'll be talking about gas and its laws. The first gas law is known as Boyle's Law. This law was named after Robert Boyle, who discovered it in 1662. In his experiment, he had a test tube shaped like a letter J, with the top of the J being opened. By pouring mercury into the open end of the test tube, the weight of the mercury would push against the air in the closed end. When he added more mercury into the test tube, he observed that the mercury would push the trapped air harder, and so the air would be more compressed. This meant that the volume of the air was decreasing. When he measured the pressure that the mercury was exerting on this air, he noticed the opposite change. The pressure was increasing. In fact, when he multiplied these two values, he noticed that the product was almost the same, even after adding more and more mercury into the test tube. To show this, we would say that the pressure, P, multiplied by the volume, V, of a gas is constant. This is in order to show that when one of these values increases or decreases, the other value does the opposite to compensate. Now, let's go to the other gas laws. Amonton's law, named after Guillaume Amontons, who discovered it in 1702, focuses on the relationship between the pressure and the temperature of a gas. However, there's this other guy who discovered the same principle in 1803, Joseph Louis Gay-Lussac. When attributed to him, this gas law is also known as Gay-Lussac's law. This law states that if the pressure of a gas increases or decreases, then its temperature also changes at the same rate. For example, before Bill drove his car, the air pressure in the tires was 32 pounds per square inch. After driving miles, Bill stops and measures again. This time, the gauge registered 35 pounds per square inch. The pressure increased because the temperature of the tires increased as they roll over the road. This is then shown by saying that the pressure, P, is directly proportional to the temperature, T. Now, imagine inflating something with warm air, such as a balloon. If you bring it somewhere really cold, you would notice the balloon gets smaller. If you do the opposite and bring it someplace even hotter, you would instead notice it inflate even more or even burst. This was the experiment done by Jacques Charles in 1787 to prove what is now known as Charles' Law, named after him. Charles' Law deals with the relationship between the volume and the temperature of a gas. Increasing the temperature of a gas also increases its volume, and decreasing its temperature lowers its volume. As with the previous examples, in symbols, we would say that the volume V is directly proportional to the temperature T, and that V over T is always constant. You've probably heard of the Avogadro's number. Well, Avogadro's law states that for two different gases at the same temperature and pressure, the volume of a gas is directly proportional to the number of molecules. Maybe you noticed a trend with most of these laws. Pressure and volume, pressure and temperature, volume and temperature, and even volume and number of moles. Now, you might be thinking, what if we combine these relationships into one? Well, as it turns out, we can. By writing all of these together as a single relationship, you can come up with what is known as the combined gas law. The combined gas law deals with all of these properties of a gas, because in the real world, all of these may vary. It states that an increase in pressure is compensated either by a decrease in volume, an increase in the number of moles, an increase in temperature, or by a combination of these. Of course, you can also write this law in symbols. You would say that the product of the pressure, P, and the volume, V, of a gas divided by the number of moles, N, and the temperature, T, is always constant, and that constant is denoted as the capital letter R.